In number 21, which of the graphs in figure 2 best shows the relationship between the pressure Y and the depth X of water in a pond? So here we need to know the relationship between pressure and depth in a liquid, and that is given by rho GH, where rho is the density, G is the acceleration due to gravity, and H is the depth of water in the pond. So the relationship between P and H is direct. So P is directly proportional to H, implying that when depth increases, P also increases, and when depth decreases, pressure also decreases. Any relationship that is direct would normally take a straight line whose gradient is different from zero. And so we have option C as the correct option. In number 22, when water at 100 degrees Celsius is heated to turn to vapor, A, the mass of water increases, B, the kinetic energy of its molecules remains the same, C, potential energy of its molecules decreases, D, the density of water increases. In this case, water that is heated already at 100 degrees Celsius, it's already the boiling point of pure water. If the water is pure, then at 100 degrees Celsius, we expect it to start boiling. And any heat that is supplied to the water at that time just goes to break the bonds of the water molecules to turn it into vapor. And so the kinetic energy of its molecules will remain the same for the main reasons that once matter is changing state, any heat that is supplied is going to break the bonds instead of heating it up or increasing its internal energy, otherwise called the kinetic energy of its molecules. In number 23, why is it important to log the calorimeter and its contents when measuring specific heat capacities of solids and liquids? To ensure even distribution of heat? No. To ensure good electrical contact? No. To measure accurate temperature changes? No. D, to prevent heat loss to the surroundings? Yes. That is the main reason for lagging the calorimeter. It consists of covering the calorimeter with an insulator in such a way that any heat that is being supplied is going to hit the solid or the liquid whose specific heat capacity is meant to be measured. In number 24, the lower fixed point of mercury thermometer is B, the temperature of pure melting ice. Yes, it is usually the temperature of pure melting ice, while the upper fixed point is the temperature of pure boiling water. In number 25, the lower and upper fixed points of a non-graduated thermometer are the 6 centimeter and the 4 centimeter marks respectively. The fundamental interval of the thermometer is, so generally the fundamental interval is the separation of the lower fixed points and the upper fixed points. Hence, that interval x should just be the upper fixed point, which is 42 centimeters, minus the lower fixed point, which is 6 centimeters, and that gives 36 centimeters. Option A then is the correct answer. In 26, how many joules of heat energy are supplied by an electric heater rated 8 kilowatts in 10 seconds? So here, heat energy should be calculated from the power times the time, and the SI unit of power is the watt. So 8 kilowatts corresponds to 8,000 watts. We are multiplying by the time, which is 10 seconds. 8,000 watts, which is the same as 8,000 joules per second, the rate of energy conversion. So when you multiply that, you have 80,000 joules, which corresponds to option D. In number 27, an object of mass 1.5 kilogram has a specific heat capacity of 450 joules per kilogram per Kelvin. What quantity of heat is needed to raise its temperature from 296 Kelvin to 316 Kelvin? So in this case, the quantity of heat energy, E, is given by mc delta theta, where m is the mass of the object in kilograms, and C is the specific capacity, delta theta is the change in temperature. So we have the mass, which is 1.5, times the specific capacity, which is 450, times the temperature change, which should be 316 minus 296, which gives 20, which corresponds to 13,500 joules of thermal energy, corresponding to option A. In number 28, a positively charged glass rod is one which has A. gained protons, B. lost protons, C. gained electrons, D. lost electrons. In the case of charged bodies, the charging is never caused by motion of protons, rather motion of electrons. Electrons are negatively charged, and whenever a body is charged, it's either electrons move to it or it lost electrons. Where electrons move, they would cause the substance they have moved to become negative because they themselves are negative. And where they have left, the substance that lost them would become positively charged because it will now be having excess protons, which would cause an overall positive charge. So if a rod becomes positive, it means it has lost electrons. If the rod had gained electrons, then it will be negatively charged. In number 29, a radio set is rated 12 volts, 100 watts. A fuse that can be used to protect the radio set must have a value of... So in the case of calculating the fuse value, the first thing is to calculate the current that would be taken by the appliance. And since it is rated 12 volts, 100 watts, power is equal to current times the voltage. And so current, I, should be equal to power over the voltage. So dividing 100 by 12, we have that the current should be equal to approximately 8.3 amperes. And normally the fuse value seeks to protect the appliance from damage when the current goes too high. So a value slightly above 8.3, the operating current for the appliance, would be appropriate for the fuse value. Amongst all the options, it is C, 9 amperes. That is slightly above the current the appliance can take. And so that is the appropriate fuse value for the radio set. In number 30, 3 2-ohm resistors are connected as shown in figure 3 below. So we have between points A and B a 2-ohm resistor which is in series with two others that are in parallel. So the combined resistance R total should be equal to the one that is in series, that's the first one which is in series, plus the effective resistance of the two others that are in parallel, which is simply given by the product of their values divided by their sum, which is also in ohm, and we get 2 plus 4 over 4, which gives 1, so giving an effective resistance of 3 ohm, corresponding to option B.